Alright, so 15 is the relation a function. Oh, actually, let me start with A. List the domain. So remember the input values, the x values make up the domain. So notice how you have two negative 2's. You don't have to write both of them, just write it once. So the domain is -2, -1, 1, and +2. Okay? The range, that would be the y values, the output. So that's this one, this one, this one, this one, this one. So I have -1, 5, 6, 3, and 7. Is the relation a function? Well, this -2 goes out to two different values. It goes out to -1 and it goes out to 5. So remember, for a function, for a relation to be a function, each input can only go out to one unique output. Now it can't go to more than one. So this is where it falls apart right here. So the answer would be, is the relation a function? No, because -2 gives -1 and 5 as outputs. And that's, that's not a function. Alright, 16. You are given a specific domain, a set of numbers, these 5 right here, okay? And here's a table to write your answer for y. So when x is -6, I'll do the work here on this side. So I've got 1/3, too late, 1/3 times -6, remember we put a 1 underneath, plus 2. So that's going to give me -6/3 is -2. So that's 0. So I have a 0 right there. Then I do the next one, 1/3 times -3 plus 2. So -3 times 1/3, we put a 1 underneath, that's -3/3. That's -1 plus 2, that's 1. Okay, then 1/3 times 0 plus 2. That's 0. Anything times 0 is 0. 0 plus 2 is 2. Then 1/3 times 3, which we put 3/1. This is 3/3. That's 1. 1 plus 2 is 3. And then 3 here. And then 1/3 times 6, we put 6/1 plus 2. So this part right here is 6/3, which is 2. Plus 2, that gives you 4. So this is 4. Okay, so now we're going to plot the points. -6, 0, -3, 1, 0, 2, 3, 3, and 6, 4. Do not connect the points, okay, because the domain is these 5 separate points, so that's how we're going to keep it. So this is a discrete graph, right? Because the points, it's made up of separate points. Okay, moving down to 17. It says, graph the following over a domain of all real numbers. So that means that we are going to get to connect this. So what I suggest you do first, though, is solve for y. So subtract x from both sides. So you end up, let me just put it right here. So minus x. So this is 0. So y equals -x plus 3. So make a table with a few values, so I'll just make it here on the side. This is for a different problem. So let's start off with, let's say, -2, -1, 0, 1, 2, let's say. So the opposite of -2, because it's minus x, right? So the opposite of -2 plus 3, that's 2 plus 3, which gives you 5. Then the opposite of -1 plus 3, that's 1 plus 3, that's 4. then 0 doesn't have an opposite, so just 0 plus 3, that's 3. The opposite of 1 is negative 1 plus 3, that gives you 2. And the opposite of 2 is negative 2 plus 3, that gives you 1. So we plot those points in our graph. Negative 2 with 5, which is up here. Negative 1 with 4. 0 with 3. 1 with 2. And 2 with 1. Okay? So we continue the pattern. I mean, we only put a certain number of points on the graph, but since it's over all real numbers, you just connect all the way across, and that's your graph. So this is a continuous graph. Okay, there's no gaps or holes. Alright, so what is the range in the following relation? So regardless of how the tables are oriented, remember the range is the output, so it's the y value. So it's going to be these numbers. Okay, so you're going to write the range (6), -4, -10, -16. And that's it. Alright, so here it says list the domain and range of the relation. So I'll start off with the domain. So those are the x values. So I'm gonna draw lines up to the x-axis or down to the x-axis like this. So this one is -4, -1. I'm only looking at the x. This is on the axis, so it's just 0. This point is on 2. And this point is on 3. So this is the domain. And then for the range, we look on, where on the y is it landing. So this point right here is, so let me put the range. -4. This point is right on the axis. It's right there at -1. This one's also at -1, so both of these are at -1. So we don't write it twice. Once is enough. This point right here on the right side goes to 0. And this point right here goes to 1, 2, 3. So there's your range. Okay, is the graph a function? Does it pass the vertical line test? If I go here, only 1 point. 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 It does pass the vertical line test, so yes. A function. How do we know? It passes the vertical line test. Alright, so number 20 is asking you to distinguish between a continuous and a discrete graph. Remember, discrete is a graph that is made up of disconnected points, whereas continuous, like the word says, is like that. So the amount of money in your bank account over 5 years, that one would be considered continuous because it fluctuates, right? You put money in, you put money out, in and out, and interest rates and everything are added in. Interest is added in over, periodically, however it's added in. So you're going to have a bank account that, will do this over time. So it will be continuous. Grade on a test based on the number of problems correct. Okay, so if there are 10 and there's no partial credit, so that one would be discrete. Okay, so if you have 1 problem correct, this is your score. If you have 2 problems, this is your score. If you have 3 problems, so this is a number correct right here, and this is the score. so this would be discrete. The height of a tree over time. Okay, so the tree is continuously growing, so that would be a continuous graph. The amount of profit made from each car sold. Okay, so this would be discrete, different from the bank account, because like if you sell one car, you get this much profit. If you sell 2 cars, you get this much profit. So this would be like for 1 car, for 2 cars, for 3 cars, etc. So the graph is discrete. The number of songs each student has in their iPod. Okay, again, that would be another discrete graph. So student number 1 can have this many. Student number 2 can have this many. Student number 3 can have this many, and so on. So this is another discrete graph. Alright, so for number 21, it says determine which of the following are functions or not functions. So for graphs, remember we use the vertical line test to test and see if they're functions or not. So this one, you draw a vertical line and the line passes 2 points. So this is not a function. The letter B, draw a vertical line, and here you even have more points, right? 1, 2, 3, 4. And so this is not a function. I'm just putting the F, not a function. For ordered pairs, you look at the x values. So here you have -3, -1, 1, -3, and 3. Even though -3 repeats, I have a -3 here and a -3 here, it has the same y, so it's actually the same point. So this one is a function. It's kind of like a trick question. Okay, you look at the next set of points. You have a 9, a 7, a 5, and a 9. In this case, you compare the 2 9s. The y's are different. The first one has a 5, the second one has a 4, so this is not a function. Okay. The table of values is kind of the same thing as ordered pairs. You know, you just look at the input at the x values or input values. So in this case, you have a -1, a 0, a 1, a 2, a 3. They're all different, so this is a function. For mappings, you looked at the input. In this case, the input is the gas and the output is the distance. So you check to see if any of the inputs go out to more than one output. So here the 10 only goes out to 150. The 16 only goes out to 240. The 17 only goes out to 240. And the 20 only goes out to 300. So that's going to be a function. Okay. Letter G is another graph. So we draw a vertical line. And no matter where you draw the vertical line, it's only going to be touching the graph in one point at a time. So this one is a function. And then the last one is another graph. We draw a vertical line. So we're okay here. But as soon as we draw a vertical line here, notice how it touches 2 points. Okay, so if it does it even one time, it's already disqualified. So this is not a function. Okay, I hope these videos help.
Okay.